Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review everything you need to know for the upcoming test on linear relations. So there's two things you need to be able to do. You need to deal with inequality regions and solve simultaneous equations. Let's start with graphing inequality regions. So you follow these steps. Graph the line, pick a test point, and then you decide which side of the line to shade. Now note, when you're graphing the line in step 1, if it's a greater than or less than sign, you used a dashed line because the region won't include the points on the line. And if you have greater than or equal to or less than or equal to, you use a solid line. So let's graph 3x minus y is greater than 6. We're going to start by graphing the line 3x minus y equals 6. So because it's not in y equals mx plus b form, you might like to use xy intercept. It actually doesn't matter. You can easily rearrange this if you want. You get 3x minus 6 equals y. If you want to graph it that way, that's fine. Use gradient intercept method, doesn't matter. So xy intercept for this. If x equals 0 minus y equals 6, which means y equals negative 6. The y-intercept is negative 6. If y equals 0, 3x equals 6, x equals 2, this is the x-intercept. Whichever way you graph it, it should go through these 2 points. Now, because we have a greater than symbol, rather than drawing a solid line, I have to draw a dashed line. So this here is the line 3x minus y equals 6. Step 1 is done. So step 2, we're going to pick a test point that does not lie on the line. So any point that doesn't lie on this line will work. If 0, 0 doesn't lie on the line, it's an easy point. I'm going to substitute 0, 0 into this inequality and see if it satisfies the inequality. So my inequality is 3x minus y is greater than 6. So subbing 0, 0 means I'm changing both x and y to 0. So if I get 3 times 0 minus 0 is greater than 6, this is saying 0 is greater than 6. Clearly, that's false. So what that means is, because 0, 0, which is here, did not satisfy the inequality, I shade the other side of the line. So all I'm going to do now is just shade this side here. So what exactly have I found? Well, here I've shaded all the points in the Cartesian plane, there's infinitely many of them, that satisfy this inequality. So any point in the region like 4, 0, if I substitute it in here, I get a true statement. All of these points are such that 3 times the x-coordinate minus the y-coordinate is greater than 6. All right, let's now look at going the opposite way when I have the inequality region and I have to find the equation. So here we're going to find the inequality of this region. What inequality do we start with to end up with a graph like this? So the first step we're going to do is find the equation of the red line. Whenever you're finding the equation of a line, you find m and find b, because the equation of a line is always y equals mx plus b. So m is the gradient, it's rise over run. So to calculate the gradient, always start at the leftmost point, figure out how you get to the other point. You need 2 points to find the gradient. So we'd have to go across 5 to the right and down 4. The rise is negative 4 because we went down 4 rather than up 4. So here, gradient is just rise over run. It's negative 4 over 5. So the next step is to find b. How do we do that? Well, we take our equation y equals mx plus b. Firstly, we're going to substitute m. So to substitute m, it's just minus 4 over 5. That's why we always find the gradient first. Now, when substituting x and y, it just comes from one of the points. It doesn't matter which one. I'll just choose this one, which is the point 0, 4. X equals 0, y equals 4. So here, the y-intercept, believe it or not, is 4. 4 equals 0 plus b. b is equal to 4. Now, that was obvious here that the y-intercept was 4. I just wanted to show you the process for finding b if you don't know it. So in any case, the equation here is y equals mx plus b. So now what I need to do is replace this equal sign with an inequality. So to do that, what we want to do is find a point that's in the region that's shaded. So an example of such a point would be a point here, say 5, 1. Any point within the shaded region will do. I'm going to substitute x for 5 and y for 1. So if I do that, I take my x and I replace it with 5. And then I'm going to take y and replace it with 1. So let's simplify this equation. I get 1 equals negative 4 over 5 times 5 is just negative 4 plus 4. I get 1 equals 0. Well, clearly 1 doesn't equal 0, so I'm going to have to replace this equal sign with a greater than or equal to sign. Now, the reason I did greater than or equal to was because it was a solid line. So my equation before was y equals mx plus b, but I've just figured out I need to replace the equal sign with greater than or equal to, and I'm done. All right, let's now look at simultaneous equations. So when we have simultaneous equations, we're looking at equations like this. Each of these equations has two variables, x and y. This has infinitely many solutions. This has infinitely many solutions. But there will be one solution that solves this equation at the same time it solves this one. And that's what simultaneous means, at the same time. We're finding the solution of this equation that's also a solution of that equation. So how do we do it? Well, we went through 3 methods: graphical, substitution, and elimination. Now, if we can avoid it, we want to avoid graphical method because it takes a long time and you have to be super accurate. So let's concentrate on substitution and elimination. This one's better for substitution because one of the variables, in this case y, is the subject. This one's better for elimination because neither x nor y is the subject in either equation. I want to point out you can use elimination here and substitution there. Use whichever one you want. I just think it's easier to use substitution when x or y is the subject and use elimination when that's not the case. So to use substitution, you substitute one equation into the other. I'm going to substitute this equation into that equation. So what that means is I take my second equation here. Now, because the first equation said y is 17 minus x, everywhere I see a y here, I'm going to replace with 17 minus x. Always use brackets when you're substituting an equation. So expanding the brackets, negative 2 times 17, negative 2 times negative x is positive 2x. I get the x's in one spot, 3x plus 2x. All right, now what I need to do is add 34 to both sides. I get 5x equals 25, x equals 5. So if x equals 5, y is just 17 minus 5, which is 12. We write the solution like this: x first, y second. So x equals 5, y equals 12 is a solution to both these equations at the same time. Let's now look at the second one. I'm going to use elimination here. So you have to eliminate either the x's or the y's. You eliminate the one that has the same coefficient number in front of in both equations. Now, if neither x nor y has the same number in front of in both equations, you need to multiply one or both equations. I'm going to multiply the top equation by 5 and the bottom by 3. If I multiply this top equation by 5, I multiply everything by 5. So I multiply 3x by 5, I multiply negative 4y by 5, and I multiply 39 by 5. I'm going to multiply the bottom equation by 3. 5x by 3, 7y by 3, and 24 by 3. The reason I multiply the equations, now the x's have the same coefficient in both equations, I can eliminate x. When they have the same sign, so these are both positive, same sign, you subtract. 15x minus 15x is just 0. That's why I did it, to eliminate the x's. Negative 20y minus 21y gives me negative 41y. 195 minus 72 is 123. Dividing each side by negative 41, I get y is negative 3. I now need to find x. You can substitute y into any of these equations to find x. I'll choose this top equation here, but it doesn't really matter. So I get 3x minus 4 times negative 3 is positive 12. 3x plus 12 is 39. Subtract 12, divide by 3, and you get x equals 9. The solution here, x first, y second. X equals 9, y equals negative 3 solves both equations at the same time, and I'm done. Let's now look at some worded problems. So in chemistry, 1 litre of a 25% solution is made from 2 formula, 18% and 30%. How much of each formula must be used? So whenever you're doing a worded problem with simultaneous equations, you always start off by defining your variables. You always let x equal one of the things you're trying to find and y equal the other you're trying to find. So in this case, we want to know the amount of the 18% solution that we're using and how much of the 30% that we're using. So after we've defined the variables, we need to come up with two equations. So we're using 1 litre of these two things combined. So I'm going to write x plus y equals 1,000, because 1 litre is 1,000 mils, and it's going to be easier to use 1,000 than 1. So that's my first equation, but I need another equation. So the other equation tells us that 18% of the first solution plus 30% of the second solution, what's that going to equal? Well, I want it 25% of 1 litre, so I want 250 mils to contain this chemical. So I've now got my two equations. I'm going to solve them. I'm going to use elimination here because neither x nor y is the subject of the equation. So I'm just going to times the top one here by 0.18. So it becomes 0.18x plus 0.18y equals 1,000 times 0.18 is 180. So I have x's with the same coefficient in both equations. They have the same sign. I'm going to subtract and eliminate the x's. 0.18x minus 0.18x is 0. 0.3y minus 0.18y, I get 0.12y, and 250 minus 180 is 70. So now I go 70 divides 0.12, I get 583.3 recurring mils. So that means I need to use 583 and a third of a mil of the 30% solution and the other 416.6 recurring mils I use of the X solution. So I use about 417 mils of the 18% solution and about 583 mils of the 30% solution. All right, let's now look at one more worded question. All right, my brother is 12 years younger than I am. In 5 years' time, I will be 9 less than double his age. How old is each of us now? So worded problem for simultaneous equations always start by letting x equal one of the things you're trying to find and y the other. So I'll just let x equal my age and y will be brother's age. So after defining the variables, we need two equations. First bit of information says my brother's 12 years younger than I am. So my age is equal to brother's age plus 12. In 5 years' time, my age is x plus 5. My age will be whatever it is now plus 5. And I'm told that that's 9 less than double his age. So in 5 years' time, brother is current age plus 5. I am going to be double his age and 9 less than that. So these are my two equations. So what I can do is substitute this equation here into the other one. I can use substitution because x is the subject of this equation. So I take this equation, everywhere I see an x, I replace with y plus 12. So I get x, which is y plus 12, plus 5 equals 2y plus 5 minus 9. Now I have one equation with one variable. I get y plus 17. Expanding the brackets, I get 2y plus 10 minus 9. Of course, 10 minus 9 just gives me 1. All right, now I solve this equation. I've got y on both sides of the equation. Subtract the one with the lowest coefficient. I get 17 equals y plus 1. Obviously, that means y equals 16. So I found that y equals 16, x equals y plus 12 is 28. So I should write a worded answer to a worded problem. So I just write something like, I am 28 years old, and you just write something like, brother is 16. It just lets the teacher know that you know exactly what you found. So that is the final answer. In 5 years' time, I'll be 33. He'll be 21. 33 is 9 less than double 21. All right, thank you so much for tuning into this video. Best of luck studying, but you will ace it. This has been the luckiest maths teacher in the world. Have a great day.